So we're going to talk today about something called a decay series. And a decay series is where we start out with a certain material, and we'll talk about what that is in just a minute. And that material is radioactive, and it's going to give off certain decay particles or radioactive particles or radioactive radiation until it gets to a stable form. And typically that stable form is something lead. But it can vary slightly from that, but typically lead is our ending amount. So let's review real quick the different basic particles that we're dealing with. The first one is going to be a helium nucleus, which is our alpha decay. So alpha is our first type of particle that's going to be given off. And again, that's very similar to a helium nucleus. So we represent it with helium because it has 2 protons, which is helium's atomic number, and it has a mass of 4. So 2 neutrons, 2 protons is going to give us a mass of 4. We can sometimes also symbolize this when we don't need the numbers with just a symbol. This is the Greek symbol for alpha. Beta particles are the next type of particle that we're going to talk about. It's another form that's given off. Remember, a beta particle is essentially a neutron that has fallen apart to give us a proton and an electron. And the electron is the beta particle that's going to fly out of that nucleus. It has 0 mass, and it has -1 for its atomic number. And then we represent that with a lowercase e for electron. And the Greek symbol for beta is a kind of a B on a little bit of a slant, and then it has a tail at the bottom. And then the last form that we talk about in this course is gamma. Gamma is pure energy. It has no mass, and it has no protons associated with it, and that is the symbol for gamma. So we're going to take these symbols here and we're going to apply them to show beta decay. And then after we get done with that, I'm sorry, not beta decay, but decay series that also includes beta decay. And then after we're done with that, we're going to graph that information. So here are our starting things. What we're going to start out with initially is uranium-235. So 235 is the mass of that uranium. Then we need to get our lower number. If we look on the periodic table, we'll see that uranium is 92 on the periodic table, and then we use a U to represent uranium. They said that we're going to give off an alpha particle. So remember from our discussion above, an alpha particle is a helium nucleus. So we represent that like this. And then we need to figure out what's being left behind. So here we started out with 235. Remember, we kind of think of the arrow as an equals sign. So 235 equals 4 plus what? Well, that would be 231. And then the bottom part we think of as another problem. So 92 equals 2 plus what? That would be 90. And then we find the symbol for number 90 on the periodic table, which is thorium. Okay. So this becomes our starting material for our next problem. And sure enough, you can kind of double check yourself here. Thorium-231 is what we're supposed to have here. So 231, 90, and thorium. And this is going to give off a beta and a gamma. So remember from above, beta is 0 minus 1e, and a gamma is 0, 0, and then we have our little fish symbol. Now we need to figure out whatever else has been left behind. So we think of this as a 2-step math problem. So 231 equals 0 plus 0 plus, that's going to be 231. And then down here we have 90 equals -1 plus 0 plus, that would have to be 91. And then look up on the periodic table for number 91, and it's Pa. And you just continue down through here until you get all the way to the end, and you should end with lead. So then we're going to take this information that we've got here and we're going to graph it. So down here I have a graph set up, and you can pause the video and get your material graphed in here if you'd like. I have down at the bottom is my atomic number. I started with 81 here at the origin, and I'm skipping every other line, 82, 83, and so forth until I get to 91. And then along the side here, I'm going to go up by 2. So 206, 208, all the way up until I get to 236, and that should be labeled as mass number. So if you want to pause the video and get that labeled, then you can rejoin me and we can get these plotted. All right, so the first one is 235 uranium. So uranium, and I guess I need to get that down here. There's 92. So uranium is number 92, and it is 235. So I'm going to find 235 here and find 92, and I'm going to put a dot there. And then I'm going to label that dot uranium. I'm not sure why this is moving on me, but it should be right there in the middle of that. And then the next dot, so we went from uranium, and then the next thing we created was thorium. So thorium is 231.90. So we're going to find number 90 on here, and we're going to find 231, and we will put another dot there, and we will call that thorium. And then we're going to connect these two dots together, and we're going to label them with an alpha symbol because we gave off an alpha. That was alpha decay. Right here, we gave off an alpha particle. So then we're going to take that thorium and we're going to go to Pa, which is 231.91. So we're going to find 231, which is where we're at right here. And then we have to go up to 91, and we're going to put a dot there. And we're going to name that Pa. And then we'll connect those two lines together, and we're going to call that a beta and a gamma because those were the two things that we gave off. And then you just continue with this until, and that gamma should be up here. I don't know why things are hopping around on me, but they are. You just continue until you get all the way down to the end, which should be down here with lead and 206. So I will stop for now and let you work on that on your own. Remember, if you need any help, I'm in the morning, and I'm also available for a little bit of time after school. So